Quick little bonus video here. I'm in the lesson 14 practice problems, and I just wanted to kind of show you how we can look at a graph and start to see what that shift might look like. Because cosine and sine actually can line up with each other if we shift them far enough, and in fact it actually has that in your lesson 14 summary, that if we shift it pi over 2, all of a sudden our sine graph lines up with our cosine graph. So there are often two ways that we can write an equation if we aren't given a context about thinking it as being height off the ground or horizontal change from the center of something. Okay, so this graph, just want to kind of show you for number 3 how you might go about this. I start by looking at the amplitude, so I can draw that midline of what's going on in here. Okay, so this has an amplitude of 2. That's why every single one of these has a 2 in front. Okay, so our amplitude. And that puts our midline right here on the x-axis. Right. So that's why we don't have anything that's adding or subtracting off here. So our amplitude's at 0. We need to think about what this shift is going to look like. And so I actually traced cosine and sine graphs on a little transparency. It's just a page protector. And so I line these things up, and I see that it's been stretched taller. So I'm not thinking about the stretch, but I'm thinking about the shift of what's happening left and right. If I start with cosine, this cosine graph, I can see that my new graph has been shifted, in this case, to the right. Okay, and so what was happening, if we find kind of this, what was happening at pi here is now happening here at about 5 pi over 4. So it moved it from 4 pi over 4 to the right 5 pi over 4. See how it took that low point and it moved it over here. So when I think about the cosine graph, it is cosine, but is shifted to the right. Okay, so cosine shifted to the right is going to look like D, this guy right here, because that is telling me that minus sign is that it's shifted to the right. Up here, this one is shifting it to the left. Okay, so it could be that cosine of theta minus pi over 4. It has shifted it to the right. Now, if I compare it to the sine graph, it has taken that sine graph and what was happening here at, as far as crossing the x-axis, normally our sine graph crosses the x-axis right at pi, and I see that my new graph has shifted it to the left. So this would be sine graph, but shifted left by that pi over 4. Okay, so what was happening at pi is now happening at 3 pi over 4. So it essentially took this sine wave and shifted it all over like this. Okay, so tracing it might be a helpful way to think about it. And now when I have that sine with the left shift of pi over 4, well, this one is shifting it to the right. So this is how I know I've picked the right one. It has to be D, because our sine graph there would look very different. Remember, you can also graph each of these on a Desmos or on a graphing calculator and see if it matches up. Just set your coordinates so that you're looking at a trig scale of 2 pi.